Oh, hey, welcome back to the man cave. Working on something a little different. Same type of deal. It's still some stuff for the laser, but I'll bring you in a little closer and show you what we got going on. All right, so what we got, as you can see on the laser, we were having some issues over there with the table and stuff kind of shaking and some other little things, storage area, that kind of deal. So, doing some of the stuff in the past, we know that these things need to be pretty solid so we don't have issues. So what I did was I jumped on Fusion 360 and I made a quick SketchUp of a table that I wanted to build. And what I wanted to do was I actually wanted to take the blue toolbox that we redid in a couple of videos back and have it so it'll slide underneath the table and have a nice top on it. Now I was able to run over to our local metal supplier here and pick up some drops and got really fortunate, found some 2x2 stuff, which is way overkill for what I was wanting to do, but hey, for the price right now. So 2x2 by like 3/16 wall, so it'll be perfect. But I took the amount of material that I was able to get, and actually I was able to get a drop of a plate to go on top that's the perfect size. So I was able to build everything and design everything else around that. So that's really cool. And here, we'll go to Fusion real quick and I'll show you what I did really fast. And then we'll come back to the video and I'll show you what I've got.
Alright, so the first thing I did was I created a likeness of the toolbox that I wanted to include in the bench. And this was to give me some dimensional reference to make sure my sizes were where I wanted them, and make sure the toolbox fit, obviously. So after I designed that and brought that into this workspace, I then created an offset plane. You can see down here in the timeline of where I wanted it to represent the top of my table. From that point, I went and created a sketch. There you go. You can see the sketch of the top of the table, or the top frame section of the table, I should say. I wanted to use the tube feature in designing this instead of component and then bringing that in and then modifying it and all that kind of good stuff. But I also wanted it to look realistic, and I wanted to be able to use my parts for a cutout list, which I'll show you here in just a minute. But in an effort to do that, I wanted to use tube, and I would have to go past the end because the tube is going to center around this line. So you make your sketch where you want your tube to, what path you want your tube to follow. I was trying to think of path, but what path you want your tube to follow. But I also needed to include on how far out it's going to go past, because I want a 45 in this corner. So that's why you see these sticking out a little bit beyond on each side. Figured out my top dimension, and then this will actually be duplicated for my lower as far as dimensions go, based off the material size that I found that I want to make the top out of. So once I got this sketched, then I started to place my tubes. So I did a square tube in the create. You can come down and create, and let's see where it's at. Pipe. I keep saying tube, but it's pipe. But you create a pipe. You click on the path you want it to follow. Let's say I want it to follow this path, but I want it to be a square one. Or, well, hey, if you want it rectangle, triangular, you can do it that way. That's how we created, or how I created the tubes in it. So I created all 4 tubes. Now my issue was getting my 45s. I played with a bunch of different things. I tried like a plane to do a planar cut, and then I have pieces I have to remove and all that. So I figured, hey, best thing to do is let me just create a draft angle. So I came to the bottom of, or not the bottom, but the end of my material here, and I would hide each component or each body at a time. As I was creating it, it was all individual bodies. I would hide the body, and then I would come to the end and I would just create a draft angle on the end of my tube that I wanted. So that's where we started doing these, and you can see here that was a draft angle on this end. And I just continued on till I got all 8 ends, basically the draft angles completed. And once those were completed, I duplicated my part and positioned it down on the bottom. There are probably better ways to have done this, and I see that in retrospect, but there was definitely been easier ways to do it. I was trying to figure out a way to do my legs and use the legs to cut this and all that, and it just got really complicated. But anyway, did my paths for my legs, did the tubes again. The tubes go all the way through the material, and I was going to use my my leg here for a cutting tool and just cut that section out, but it wouldn't do it, and I could not figure out why. Well, it's because I made a copy of this and I had draft angles. So what I did to get around that was I just came back and zeroed out my draft angles. Basically, I just removed the 45 degree, and that's where we ended up at. So came through and created components out of all these items, and the reason being I created components was in order to transfer this out to a cut sheet. A cut sheet needs to see components. It won't look at bodies, so it has to see all the components. Came back out, resketched the top on top of this surface, and made my top plate. And this is my aluminum tabletop. Now, the other thing that I could have done that would have saved me a bunch of time if I would have, had a little bit more forethought about it was I could have easily laid out my markings for my bolts, where I wanted to bolt the top down, because I wanted to do all 4 corners obviously, and then halfway in between, and then halfway in between these marks, and it would have been really simple. And I could have done just one more cut sheet that would have shown that, and it would have gave me all the dimensions, but I didn't, and that was my fault. That was my mistake. Here's a copy of my cut list. And one of the things that I did do was I wanted angular measurements on my cut list, references for checking to make sure everything was in square as I built this table. So that came out really handy. Now I will tell you, spoiler alert, I designed this whole thing off of 2x2 tubing, as I said in the video to start with. I got 1 3/4. I did not even measure my tubing size before designing this. And the only problem with that was my cross beams here on the bottom were too short, and I had just enough material to build this, surprisingly enough. So what I ended up doing was, since I was only a quarter inch out, I was able to just inset these legs on the corners just enough to make up the difference, and it actually ended up working out really well. I like the fillet weld joint that I was able to get here all the way around, and it actually ended up working out really, really good. But yeah, I mean, the great thing about this was I was able to look at this and say, okay, I need 2 pieces 27 inches, I need 2 pieces at 42 inches, and those needed 45 degree cuts. And then I was able to come back and figure this out and say, okay, these are my tops. I need 4 legs at 39 inches. I need 2 pieces at 23 inches and 2 pieces at 38 inches. And boom, there it was. Everything was cut out and done.
Okay, now that you've seen that, here's what I was able to do. I made some prints, not very fancy stuff, but there's capability to do some of this on Fusion. I was able to take my material, lay it out, because I had a couple pieces that were, what was my lengths on them? 2 pieces at 132 inches, 2 pieces at 118 inches. So I was able to lay it out to have very, very, minimal scrap. Of course, my top pieces are going to have 45s, as I showed you in the video, or in the Fusion 360 stuff just a second ago, and the rest of it will be all straight. So yeah, what we're going to do now is let me move you back a little bit. What you can see here now is we got our cuts. This is our top pieces. These are our bottom square that we're going to have actually where the toolbox and stuff sits on, and these are the legs for the unit. So yeah, we're going to see if we can get this all mocked together and welded up, and hopefully it's square. Got some casters coming. Hopefully they'll be in tomorrow, and so that way this thing can sit on the floor rigid all the time, and then when I want to move it, you just pop the casters down and it'll raise it up, roll it where you want it. And but anyway, let's get putting this thing together. Let's get our pieces cleaned up and prepped, and let's see if we can stick some aluminum together. I don't know if I remember how to weld it or not, but we're going to find out.
Okay, so this is the top of the table welded together. These are some nice little corner jigs that I picked up from Amazon. These things work really well in holding stuff square and true as you're trying to tack it together and weld it. So as you can see here, I got the leg and stuff on it, but I'm not going to bore you with all the other details. So let's get at it.
Got it welded together. We're going to put the casters on it. You can see here where I've drilled the holes. The caster kit came with a pretty neat little template setup and stuff. So yeah, let's bolt those on and see if we can get this thing flipped over and maybe get a toolbox mounted on it. We don't try to put them on upside down, but it came with a template. Of course, the template said to put it on the center hole, so we're not listening to that. I'm gonna put it on the two outside ones. So I've drilled it, tapped it, and we've got the screws to put in it. But it fits on here like this. Obviously, it's upside down. Well, it fits on here. When you want to move it, you flip it up, raises it up about 3/4 of an inch off the ground, roll it around where you want it, flip it back up, and we're good to go. So let's get them bolted on. All those are on. Let's flip this puppy over, see how she works. Oh. Here, get you flipped up. And there we go. Alright. So, yeah, when I'm not using it, she sits down on the floor on all fours. The floor's not the levelest in here, so may still put some leveling jacks on the bottom, we'll see. But when you want to go use it, I'll show you on the other side. Or when you give a little kick over, and there it is. Position set up here for the toolbox to go in, so that's going to be the next thing we're going to do. Put that in, and then put the top on it. All right, so we've got the cart together. Came together really nice. Cabinet is installed, so that, I mean, everything actually worked out as it was designed. Got a filler piece I'm going to put up here, you know, kind of dress it up some. I left these areas open. I haven't decided exactly what I'm going to do with those yet, whether I'm going to put shelves in it or what have you. I may put a air filtration deal in it. Depends on if I build it an enclosure for the laser. Now what I've got going on here is something that's kind of interesting. I don't remember if I showed this in another video, but I made some stands to mount the laser to it so that it actually has a captured nut in it now. I think these are 8mm bolts, I should say, not nuts. And this will bolt down to this table in 4 spots. And I've threaded the table so it'll bolt on there securely. These pieces here are adjusters, and what these do is once it's bolted down, these will fit on these nuts or bolts. All right, they will bolt on here like so, or thread on like so. And once this is bolted down, if you need to level this, if you need to level the laser itself, you can do that by simply adjusting this up and down. You would hope that, you know, your floor's level and all that kind of stuff. But if you're going to run a rotary attachment, a rotary chuck or anything like that, you have to have stands to raise everything up. That's where these come in. I have built these stands. These stands will thread right onto this. Boom. And I actually made 3D printed thumb screws because it's not really so much about, trying to hold it on. But if you don't like the idea of the 3D printed thumb screws, you can use, I believe these are 5, 6, or 8 millimeter. Yeah, these are 8 millimeter. So you can get yourself a small 8 millimeter bolt, put in there. So yeah, but then once you've got all this stuff on and everything is set up the way you want it, you set your rotisserie up, your rotating chuck in here, you level it up, then you can set your level on your machine and make sure it's level also. But yeah, we've got that. I've got a piece of wasteboard I'm going to put on here because some of you may be wondering about the thickness of these. These do raise it up roughly about a 1/2 inch over what it normally sets. And if you have a laser that doesn't have an easily adjustable Z height on it, that may be a little bit more of a hindrance. But what I've done is, obviously your laser doesn't make it out this far, so I've got a piece of 1/2 inch material that I'm going to use for my wasteboard that's going to fit inside here. So my laser will still be on the same height it was before. Okay, this I'm sure is not the next scene you expected to see. Was it the next scene I expected to see? But this is where we're at. Had a camera malfunction. My my other recording camera quit focusing, so we had to send it in for repair. So we're going to do this one from the phone, and I'll just, everything else is done. I didn't know this didn't focus till I went to edit the video. But anyway, here's where we're at. All right, ignore that. That's coming in a later video. Anyway, the table's done. I mounted my computer stand on the table, bolted it through on the bottom. It's really rigid. Everything is tightened up. So my all-in-one computer is working well. My keyboard mount and mouse and all is working really well. So that works good. We bolted this sucker down all the way around. Got the laser mounted up here with the feet and the adjustable feet so we could adjust it and level it. Got the wasteboard mounted. It actually works out perfect on this laser. That is actually a 24 by 24 board. Fits right in there. Perfect. So yeah, that's all good. I mean, this thing fires up, it works good. We've done some testing. As you can see, we've added a couple extra things, and we'll go over that in the next video. But sorry that we missed out on so much of the other stuff. But hey, that's the way it goes sometimes. So now, if I want to enclose it, I'm not sure yet, but we'll figure that out as we go. Well, thank you for watching. Sorry that there's gaps in the video due to the recording. I've done the best I can to try to catch you up to date or up to speed on what's going on. Did get the Atezra fixed, by the way. Parts did come in for it. It is up and running. I may do another little short video on updating that stuff. I don't know, but we'll see. I'm about burnt out on updating on that thing. Anyway, yeah, got another video coming out here shortly about adding a camera on, which you just kind of saw in that last clip, and it works really well. So you stay tuned for that. If you got any questions about any content that you may have missed or I may have missed recording in this, drop me a comment down below. You can email me at mancavegarage1970@gmail.com. And I'll be happy to answer any questions I can. I will, keep right on going. So we'll look out for the next video, and hopefully we're going to get back to working on some car stuff very shortly. Very shortly. Anyway, y'all have a great one. God bless.